Hey, this is TJ from smokescreendesign.com. Today I've got an interesting video about the Fry Canyon in Utah. This was a balloon that went up by Worldview, and their mission is to take the, average person, average person with a lot of money, to go up in a balloon to see 120,000 feet above Earth and see the curve. So that was specifically mentioned in their mission video that they want people to see the curve. Now, this Worldview balloon test flight was, some pretty amazing footage. And so what I did was take a bunch of screenshots from this video and I did some analysis on it. Took a while. It's a lot of detail here. So what I want to do first is let's watch the video so you can see what I'm talking about. Not going to watch the whole thing, just this one specific part. So here we have Worldview, and this is their test container that eventually be scaled to fit, I don't know, 6 to 8 people, whatever it was. So this is their 10% scale test article, spacecraft, October 24, 2015. Here's the airport that they flew from in Arizona. And here's a shot above Arizona. And it didn't fly too far away from where it originated up. So here we go. So here's the footage that I took the screenshots of. Extremely difficult footage. For one, and look at all of this humidity, atmosphere. It's just not extremely clear everywhere. Got a lot of moisture in this area, so it's hard to really see the ground versus the sky. Where's the line of horizon for land? Just extremely difficult to work with. I was still able to make out a lot of details of where this place was. Just another shot from this. And here it came landing in. Alright, so I just want to play this footage here. It's really short. Alright, so we can see here that there's a really bad curve. So this camera pointing down is definitely a fisheye lens. Possibly this could be fisheye lens, but we don't see an exaggerated curve like that. Not sure. We can see the difference in the skyline. We have a lot of what appears to be a lot of cloud or something here, but not as much here. So it's really hard to really do a whole lot, but I wanted to go ahead and do something with this anyway. So that's how I came up with this, and I have 9 screenshots from the beginning all the way to the end, and what I had to do was lay them over each other, and you can see in the horizon how the horizon goes up because of the camera's movement. I did my best to line up parts of the landscape, which was really tough because just click on this, I can show you. Let's get rid of most of these. So you can see here's how the camera starts out and here's how it ends. So just extremely difficult to get everything matched up. If you look at, we've got this little curved line in here in this ridge. So you see it shifts up when I add 10 and shifts down. So just some different things. So I'm going to take a look at here. We'll compare some of these. And let's go to Google Earth. So this video may take a while because there's just going to be a lot of details to really go into. Now this area is right in here, which you can see it all the way up there like that. So we are in Utah. Should be this area right here that we're looking at. Yep, so you can see here's the curves in the water. Here's going to be the Mount Helen Peak that we're looking at. So don't remember where that I don't remember exactly where they started out at, but I think it's somewhere over here. Let me just zoom in real quick. Yes, I think here's the dam. So here's the dam, here's the airport where they started. So they're in Page. And they said their flight was 100,000 feet. So I'm assuming that the footage we're looking at was 100,000 feet. Oh, come on. So the camera is looking up somewhere around here, so it may have could have been anywhere from 70 miles, 75 miles away from where it started. Possibly, don't know exactly because it was 19 miles up. Alright. Now, one thing I found interesting with the landscape is that, let's bring this in. Was trying to match up this landscape with what I saw in Google. Very difficult to do. So I flatten this down. So here I call this the pig face because this kind of has a look of a pig snout. Here's Mount Ellen. Over here we've got Pastora Peak. And these are going to be some things that we're going to look at. And here we have this ridge, and that just has this line that goes straight up into this area here. Now it's a little hard to tell with this image. Let me try deleting it, hiding some of these layers. But you can see the pig face, the snout, the top and bottom are kind of straight away from where we're looking at. So kind of straight up and down. So I've got this straight up and down. And if we notice that this here runs in about a northwest direction from where we're looking right now. Photoshop. So let's see here. But if you look at this, kind of hard to see this line, but what did you just do that? Let me grab this. But the line is actually running in a more of a western direction than in a northwest. So I started finding this inaccuracy here. and see how close this is. So we're looking at 100,000 feet, 19 miles. So notice how big this was, and I was trying to match that face. So I see that that's just too small, so let's get it bigger. So I was like, okay, that's kind of close. It's kind of close. Maybe a little bit more. But Google down here tells us we're at 46 miles away. The eye altitude is 46 miles away. But this is, I mean, this is pretty close to the size that we're seeing, and we're only 19 miles away here. Let me try taking some of this stuff away. Don't need it. So here we have Mount Ellen Peak. And nope, that's not it. Trying to find this. Mount Ellen Peak is 11,500 feet. So you can see as I'm getting rid of some of these lines so we can see better, that at 19 miles up, I mean 11,500 feet, that looks like nothing. So I measured the distance from the edge of this, what I call the pig snout. Try to get it pretty far in here because we can see some terrain. So we're looking at about an estimate of 147 miles. Now at 147 miles there should be a 0.273 mile drop. Now it's easy to say, well, we don't see a drop, but it's hard to really see a drop. It's just not clear. And then from this height we have to ask, what would a drop look like? That's kind of difficult to really depict. Here we have the bear's ears. There's the east and the west, and that's where this ridge goes into. That's at 9,000 feet. Here at Great Point is just over this ridge, just on top of it. So just to get a reference, so we've got 11,000. Let me get back there. Where are you? Got a lot of layers. So we got 11,500 feet. We have 9,000 feet, 5,200 feet. Here in this area, it's around 4,000 feet. So we've got a little over 4,000, a little under 4,000. So we can see the differences in the elevation. Back here is Mount Peel. That's 12,700 feet. Here's Pastora Peak, which I mentioned. That's 9,400 feet. We bring 10 back in. Pastora Peak. And we have Chuska Peak at 8,800 feet. Now, with my measurement going from over here, it's estimating. I spent a lot of time just really examining the details that I could see. Going from this side of Mount Ellen Peak and going over here past Chuska Peak, where you can see where it starts to end. Got about 225 miles. That's what we're looking at here. But I'd love to get a hold of the original video footage and see if there's anything better in there. So from Mount Ellen Peak to over to this side past Chuska, we got 6.39 mile drop and curve. I mean, that's pretty big. Now the issue is with not really being able to see land detail, we can't really determine what type of drop there is or if there is any. Very difficult. If we had some trails in the sky going across, that would give us some really good data to work with. Now let's come back over here. There is what appears to either be where water runs and it's dry or where water is running. I did some measurements using Google Earth and I got a 2-mile measurement here and I got a 3-mile measurement here. So what I wanted to do was in this area is to give you a point of reference of if there's a 2-mile drop, what that should look like as far as the distance. Because when I say 2 miles on here, you might think, well, 2 miles could be, a huge distance here. But 2 miles from 19 miles up, think about it, that's pretty small. 3 miles, that's pretty small. Take those two and have the leftover. You see that 1 mile is a really small distance. So you think about this ledge here being 5,200 feet, and then the peak of this is 9,400 feet. We've got about, 4,200 feet difference. Not quite a mile, but from here to here. Now coming back over here, let me drop this layer out. From this side of Mount Ellen Peak to just past Pastor, in the middle between these two here, is a 150-mile distance, an estimate. Let me see. Yeah, so this line should actually be over here. I was basing that off of layer 10. So we should see almost a 3-mile drop between here and here. Here to here should be 3 miles. Now, remember, this is a 3-mile distance right here. But as you move closer to the camera, the size and distance will grow. As you move further back, the size of this distance will shorten. And what I mean by that is perspective. So 3 miles up close will be this big, but further back you go, 3 miles will shrink. That line will get smaller. Let me show you what I mean. I just want to try to make things as clear as possible, and you can see how complex this is. All right. So let's say let's do 20 miles. So we see this line is 20 miles from here to here. Now if we go up here, trying to get to 20. So that line is 20 miles, and you can see that that one is smaller than this one because of perspective. Think about the railroad tracks that get smaller and closer together in distance. They're the same width apart, they just looks way smaller, okay? So I just want to make sure that that's clear. So when you look for drop and curve back here, you can't use this as a measurement for back there, and the further away you go, it becomes more accurate. And I can get rid of this. So let's see, pestle or peak. Let's try something here. So what happens if I take a line going from this peak, and this really won't prove anything, but just kind of interesting. To go from the base here to the base here. So when I did that, I was like, okay, so we don't really see any sort of curve happening here. But then also what I did was I said, well, let's do this. What if I drew a 90-degree line? Okay, 90 degrees. Alright. Draw a perpendicular line. Now, at this distance, 120 miles, 140 miles would be 2 degrees of change. And what do I mean by that? If you have a circumference of Earth that is 2,491, 2,000, guess I should, 24,901, there we go. Let me get my numbers right. That's what the circumference of the Earth is supposed to be in miles. Some people just say 2,500 or 25,000 because it's easy. So 24,901. If you do that with 360 degrees, it might be the other way around. 360 divided by, no, that's right. What you're going to do is you're going to get a degree of change, which means, I'll tell you in a second, 69 point, I forget, it's like 169 or 109 or something like that. So it's roughly 69 degrees, 69 miles per degree of change. Now what does that mean? That means in 69 miles, if you have an object 69 miles away, this object will lean 1 degree away from this one. In another 69 miles, this object will lean 1 degree away from this one, but will lean 2 degrees away from this one. Now this is 120 miles. Let's just go with, this is 150 miles to here, so we'll go with 2 degrees of change. So if I pull out my measuring tool, can go, and this tells me it's 90 degrees. Let me go higher to 90. So I need to go to 88 degrees. It's 88.2. So this is, let's see, 88. So this is going to be 2.2 degrees of change. Now if you see here how difficult it's going to be to really see a 2-degree change from let's go down here. That's 88.5, but it's just extremely difficult to see 2-degree change from here from this mountain to this one here. How are you going to notice 2-degree change? That's assuming that this is the way things work accurately. Very difficult to do. And that's why experiments are important. So we see a lot of experiments where people are taking footage of areas that shouldn't be seen over a certain distance of curve using the line of height. So that's important, using the line of height measurements. Now, if something that is interesting and may or may not show evidence of something. So I saw these trails and I estimated, I mean, it could be a lot further, but I estimated that from that end of that red line down to this one is about 150 miles. Now, this one over here is a little shorter, but with these lines, I don't see really any curve, and they look lined up with these lines pretty good. But this one did curve at the end, and it's hard to tell if this one goes with this one or this here, but it appears that it goes with this one. So I don't see any curve, but again, if we're looking at 150, 120 miles on this one, we're looking at a 2-degree change. So I'd say that this is something that won't necessarily say a solid evidence, but it does start to point to looking more closely at details and saying that, yeah, it's very possible that there's no curve at all. I mean, they look pretty straight to me. Now, people have used this video as proof that the Earth is flat, and it really does appear to be flat. And we are 20 miles up, and we can see these mountains that are, you know, like between this area down here and this mountain up here. We're looking at about a 7,500 foot change. We're looking 7,500. I mean, it's well over a mile difference high between here and here, but look how insignificant that looks. It really doesn't look that different between here and here. So let me just pop everything back on and just see if there's anything else that I wanted to take a look at here. Rid of those green lines. So this was just my analysis and estimations that I got from Google Earth and with Wiki. But I mean, we've got some distances here to work with. I can't say it's really cut and dry as proof. Some people have used this video as proof that the Earth is flat. It definitely looks flat, but that's one of the big issues with the globe, is that they say locally it's flat because it's going to look flat locally. And from this far side to this side over here, we have 225 miles, which would be, as I believe I said, 6 miles drop in curve, and it's going to be a little over 3 degrees of change. So it'll lean. Now, if you look right here, I've got this green line and I have this white line. Let me bring these back in. Trying to find. So I had this green line that I made, unless it's already there and you just can't see it. But that was the 2 degree of change that I made in this picture. So from the green line to the white line is the 2 degree of change. Not very convincing. Yeah, so you've got this green line here. The white line, that would be the 2 degree of lean. Now it doesn't appear to me that there is any lean here. But it's not a perfect picture, and that's really hard to tell. Like I said, we've got 150 miles and 3-mile drop, so shorten this line a little bit. We should see this much drop from left to right, and we definitely don't see that as it appears. Like I said, what would that look like? So we need a good basis to go off of what it would look like at this point in this area. What would it look like if there was that drop? So here is, well, that's not the 3-mile mark. The 3-mile mark would be down here, but 3 miles, we don't, I mean, I definitely don't see this kind of drop here. So that's all I've got with this. I just wanted to share this with the research that I'm doing, and just the extreme, nutty, detailed analysis of this. And just Google Earth, I mean, it really doesn't match very well. So if I go down to, let's go down to the 19 miles where it should be. The here's 15. So here's 19. It's hard to get all this stuff in the picture too. So it is close, but definitely just a lot of issues that I came across when trying to look at information from here. But like to hear your thoughts about it. I know some people would be upset because they get upset when I make videos like this because I don't prove the flat earth and I don't just say, look, it's flat. Because like I said in my other videos, I want to be factual. I want to be accurate. And I haven't seen anyone do detailed analysis like this of pictures or the camera shots from balloons. I've seen people lean stuff back, but the curves are always really exaggerated. So just like to hear people's thoughts, and if you want to whine about how I didn't prove the earth was flat and I didn't just say, look, it's flat, and just be done with it, well, you can cry about it. That's your problem, because I'm not involved in this propaganda war of using disinformation just to try to prove something. I want it to be accurate. I want people to know that when they come to watch my video that I'm doing the absolute best that I can to make it the most accurate, and try to not be biased, saying that I need to look for only things that point to a flat earth. So like I said, there are things here that appear that this this appears that it could be flat for sure. Does have the appearance that it could be a local flatness even at 150 miles, but I don't see any leaning here. And I'll just end it here instead of continue to go on. You can check it out, Fry Canyon, Utah. You can do your own analysis and leave your comments below.